So, hi everyone. I am Anuj Kumar, working as a Prime Minister Research Fellow in IIT Roorkee. So, this is the assignment one of the course, NPTEL course, Colloids and Surfaces. Okay, so in this assignment, I will be discussing some basic questions related to this course. Sorry, related to this course and one numerical problem in this session. Okay, so first I will go to the first question is that says arrange the following in the ascending order of their particle size. So you have to just arrange this solution in the ascending order of their particle size. First one is the true solution, and second is the colloidal solution, and third is the suspension. Okay, so this is a very easy question. So you just have to reference this table. Here are some details about these three solutions, that is about true solutions, colloidal solutions, and suspensions. So you can see here the size True solution have a size of less than 1 nanometer, and for the colloidal solution, you have a size of 1 nanometer to 1 micron, and for suspension, you have a size greater than 1 micron. So you have to just arrange on the basis of these values. So the right option will be the second one, because the true solution has a particle size less than 1 nanometer, and colloidal solution have a particle size in the range of 1 nanometer to 1 micron, and greater than 1 micron are called suspensions. Okay, so you can see here the other properties also. So uh, just like the important property is the scattering of light. So true solutions have a very less particle size, so they do not show any scattering of the light. For the colloidal solution, they always show this scattering, that is called the Tyndall effect. And for suspensions, they also show the scattering of light. Here are some examples. If you add some salt in the water, and that the homogeneous solution is called the true solutions. Similarly, for colloidal solution, you can treat milk as a colloidal solution, and mixture of sand and water is an example of suspension. Okay, so another property you have to just uh, focus on the visibility by naked eye. So you can't see by the naked eye, you can't see the true solution by naked eye. Similarly for the colloidal solution, because they have a very less particle size, but in the case of suspension, you can see clearly the suspension by naked eye. Okay, so there are some basic properties of these three solutions. On the basis of these values, your question is solved. The second one is there are some different mechanism given here. So basis on these mechanism, you have to just select the right options. So these are your options. So first is the adsorption of polyelectrolytes. So polyelectrolytes are the polymers having positive or negative charge. So basically, before going to the option selections, we have to just go to the mechanism that are responsible for generating surface charges. So first is the dissociation of functional group. Second is the adsorption. There may be adsorption of surfactant, there may be adsorption of ions, and there may be some adsorption of charged polymers. Okay, so if you have the functional group like this on the surface, so it may dissociate in COO negative H positive. So this is also a reason for generating the surface charge on the colloidal particles. Or if you have any colloidal solution, and you just add any surfactant having positive charge or negative charge. Accordingly, it also generate the surface charge on the colloidal particle. Same, the charge can be the H positive or H negative, or maybe any ions. And fourth one, there can be adsorption of charged polymers. So you have to just select the mechanisms. So these are the charged polymers. So G and H. Here are two options for the adsorption of polyelectrolytes. Okay, and for A and B, you can clearly see here are the dissociation of surface groups. So A and B mechanisms are the dissociation of surface groups. And here you can see the adsorption of ions on the particle surface, and similarly here are the adsorption of surfactants, because here is this is the tail and head, because surfactants is just exist like this structure. So this works as a tail and this works as a head. Okay, so E and F will be the adsorption of surfactant on the colloidal surface. Okay, so the correct option will be this one. Okay, G and H, and this is second, and 6 and A and B. Okay, so this will be the right answer. The second question, the third, sorry, this is the third question. This is a table given below. It represents basically classification of colloids. You have to select the examples for that particular term among the following examples which are given below. So you have paint, smoke, dust, leather. You have to just select what is the dispersed phase and what is the continuous phase in these, and you have to just select the examples. So you have to just two examples. Okay, so first is the dispersed phase. Okay, first dispersed phase is liquid. Okay, and the dispersed phase is liquid, and dispersion medium is gas, or you can say the continuous phase is gas. So where these are liquid, dispersed phase, and gas is the continuous phase, you have to just define that colloid as a aerosol. Okay, so you have to just select the example so everyone knows that smoke and fog. Okay, there are two examples for this. Okay, so you have to 3 and 6, because in fog there are liquid droplets dispersed in gas or air. Okay, similarly for liquid and gas, so you have to just select the options. Here are smoke and dust, because the solid particles are dispersed in the gas. So you have to just write 2 and 4. Okay, similarly for gas is the dispersed phase and continuous phase is liquid. So you have to just select another option. Leather, you can say, and okay, the whipped cream. Okay, so these two options will be appropriate for this 5 and 7. And solid and liquid, you just know one, paint and ink. Okay, 1 and 8. So you have to just reference this table for selection of the appropriate options. Okay, these are some basic information. So these are the correct options. You can see here accordingly. So the third question is, you have to just select the which is not a thermodynamically stable colloid. Okay, so these there are four options. That is, first one is the micellar solution, dispersion of charged colloid, microemulsion, and polymer solution. So before answering the question, you have to just know about what are the thermodynamically stable colloids. Okay. Okay. So uh, sorry for that. So this is basically what you have to know, the micellar formation. So formation of micelle beyond the critical micelle concentration is the example of the thermodynamically stable colloids. However, when the concentration of micelle increase with the addition of surfactant to the system, the spherical micelles may become thermodynamically stable. That is another thing. So what happens in this case, if just you are having a colloidal solution. Okay, just like not collider, it is a water. Here are the air only. Okay, so if you are adding successively the surfactant molecules in this, uh, a position at which this surface the surface is saturated with the surfactant molecules, then it forms the micelles. So that concentration at which the surfactants forms these micelles are called the critical micelles concentration. So if I we will try to understand from some graphs. So this is the surface tension, and this is the concentration of surfactants. So initially, if the surface tension of the water is here, so as you all know, the surfactant decrease the surface area. Okay, so I am adding the amount of surfactant. Okay, and the surface tension is gradually decreasing, and after a point it is going stable. Okay, so that concentration is called the CMC, that is the critical micelle concentration. So at which what will happen, there are some micelles formation. Okay, just like this. Okay, so this is a example. So you can just study about it in more detail in many of the books. Similarly, if you have a charged solid particles, they are basically the kinetically stable lithophobic colloids. That in as a special case, that may be exist in the colloid crystalline phases with they can have the body centered or face centered cubic structure as a consequence of thermodynamically favors the reduction in free energy. Okay, so if you have some solid particles and they are periodically arranged, okay, so they may be thermodynamically stable, but the dispersion of the charged particles is the kinetically stable like a phobic colloids. So same for the polymers and the microemulsions. So if we talk about the thermodynamic stability of these polymers and microemulsions, so you have to just consider an example. So you have a salad dressing, you have to show just that oil and vinegar uh, do not mix. So I can have the emulsion in this case. So if I add a surfactant with molecules containing both oil linking and vinegar linking part to the mixture, the surfactant molecules will preferentially position themselves at the oil vinegar surfaces. Okay, so it will hold out both the surfaces, that is hydrophilic and another is the hydrophobic part. So basically one can have the stable mixture consisting of very small oil droplets which are dispersed in a vinegar. Okay, or they can be a reverse formation also. So this is due to the addition of surfactants which contains both the moieties, that is the hydrophobic and the hydrophilic. So it just binds both the part. Okay, so that is also categorized in the thermodynamic stability. And the same situation can arise when we okay, when we mix two immiscible polymers, just like example, this polymethyl butene and polyethyl butane. Okay, so when they are mixed, so such homopolymers can form a coarse blends. Okay, basically coarse blend, that is a non-equilibrium structures. Okay, so you can the each polymer separated, but they are only kinetically stable. Okay, if we add the corresponding diblock polymer, basically what is the diblock polymer? A polymer that contains, in this case, it is containing a chain of polymethylbutene. Okay, and it also contains the polyethyl butene. Okay, so the synthesis of this type of polymers is basically done by the controlled polymerization reaction, that is a different part of. Okay, so these are the polymethylbutene and polyethylbutene. So they when the diblock polymers is added such kind of the mixture, so they that provide the stability to the whole systems. Okay, so on the basis of these study, we have to just select which is not a thermodynamically stable colloid. So this one is the dispersion of charged colloids is not a thermodynamically stable colloids. Okay, before I go to the next question, let me check. Okay, Okay, which of the following is example of association collide? So you have to just this is a I have already discussed about it. The association collides is basically uh, aggregation, or you can say the particles that combine with each other to form a aggregate. Okay, so just you have to select see the micellar solution, and there are large number of ions. They are thermodynamically stable, like I have already said. So these are the associated molecules like micelles. Okay, dispersion of charge collide is not an association collide. And microemulsion, yes, microemulsion are is the also example of association collides. So this is just like microemulsion is just like if you have a oil droplets here, and the suspending medium is water. Okay, and some surfactant is added here. So this is the known hydrophobic part is attached to this oil droplet, and the water and the hydrophilic part is in the connection with this dispersion medium. So this is stabilized like that. So this type of mite is called the microemulsion. So ink is basically what is ink. The dye is dispersed in water. Okay, so this is not a association collide. So one and third option, that is the fourth option, fifth option will be the right answer for it. Okay, so this is basically the definition for association collides. So association collides are those collides that behave as a strong electrolyte at low concentration. Okay, but exhibit colloidal properties at higher concentration due to the formation of aggregated particles. Just like I have discussed example of micelle formation. Okay, in that scenario you are adding surfactant concentration gradually, and at some particular concentration it shows uh, the colloidal property, that is the aggregation. Okay, so association colloids have generally high molecular mass. Okay, so they basically contain, they can have the lipophilic character and the lyophobic also. uh, okay, so this is the basic definition. So just fifth question I will discuss. This is also a very basic question, that is the which of the following will be easily coagulate in the dispersion medium? Lyophilic colloids or lyophobic colloids? You all know, if the dispersed phase, that is the solid, tend to attract dispersion medium. Okay, so for example, if I have these solid particles are dispersed, okay, and this is some solvent. So if they have more affinity than the, they tend to remain with this solvent phase. They are basically colloids, lyophilic colloids. Okay, and in in other scenario, if you have this, just like sedimentation, you can say sedimentation. So if the colloid particles have no affinity, okay, with the dispersion medium, they tend to repel the dispersion medium, so the resultant soil is termed lyophobic soil. So the examples of lyophilic soils are the gelatin, starch, and you can study more example about it. And uh, similarly, the example of the lyophobic salts, that is the salts of metals and metal hydroxides, metal sulfides, are the lyophobic salts. So hydrophobic salts, that is lyophobic salts, can easily coagulated in this dispersion medium because they have no affinity or interaction with the dispersed phase. Okay, so this is basically a numerical example. So you have to just so consider a spherical particle on of four of this diameter. So these particles are functionalized with carboxylic groups. So these are the carboxylic groups. Okay. If the number of carboxylic group per particles, so number of particles are given there 2.3 into 10 to power 5. Okay, so you have to just calculate the surface charge density. Okay, and the answer should have these units, microcoulomb per centimeter square. So you have to just calculate the value of x. Okay, just try to calculate, please. Are you hearing me? Okay, survey can I find assignment first solution. So after the last date, that is, I think for assignment one is 10 August. So you will get the solution for that. Okay, first, okay. So try to solve this question. Okay, or if you have any doubt till question 5, you can just write in the chat box, please. I think I am not getting any response. So can you hear me? Just say yes in the chat box, please. Okay, answer is 0.73. Okay, but Ravi Ranjan Gun answer is 0.73 and 3.7. Okay, I will just try to solve what will be the answer for that. Okay, so this is the surface charge density. You have to just calculate the surface charge density. Okay, so total surface charge you have to calculate. Okay, I'm doing just full screen. Okay, so you have to number of charge into, okay, divide by area, that is in the spherical particle. You can have the area is 4 pi r square. Okay, so if you have the carboxylic acid group, so it will have a negative charge. Okay, so it will have carboxyl group have basically one negative charge. So one electron have 1.6 into 10 to the power 10 power minus 19 coulomb. Okay, so you have to just to calculate total surface charge, you have to just multiply it by 1.6 into 10 to power 19. Okay, so let me just check the number of carboxyl per particle. Okay, so the number of carboxyl is 2.3 into 10 is to 5 and into 1.6 10 to power minus 19. Okay, so just convert d square by 4. Okay, so that will be cancel out, and 2.3 10 to the power 5 into 1.6 10 to the power minus 19. The unit is coulomb divided by pi d square point 0.4 point 0.4. Okay, so this is the micrometer square. Okay, so let me just what just you have to write 2.3 1.6 10 to the power minus 19 just equal to 3.14 4.4.4. Okay, just calculate it. Oh, sorry, into 10 raised to 5. 3 into 1.6, that is 3.68 10 to the power minus 14. Okay, and in the denominator you will get 0.4 0.5024. Okay, and 3.68 divided by 0.5024, that is you will getting 7.32 in 10 to the power minus 14. Okay, so I am just writing on this slide 7.32 14, that is coulomb micrometer square. Okay, okay, and 7.32, that is 10 raised to 6 microcoulomb. Okay, and just you have to convert centimeter in centimeter square. Okay, so 1 micrometer is 10 to power minus 6 meter, or 10 to power 2 centimeter. Okay, so 10 to power minus 4 centimeter. So you can just uh, here 10 to power minus 4 square centimeter square. Okay, after that you will get 7.32 10 minus 14, sorry, 6, and minus 8, that is plus 8 microcoulomb per centimeter square. Okay, so you will get just option 7.32, because 14 minus 14 10 to the power 0. So I think this should be the right answer for this. Okay, just check your answers, please. If there is any problem, please type in the chat box. Okay, I think that is okay with you. Okay, I will just ask uh, Rabi Ranjan Murmu. That is okay. Your answer was 0.73. Just verify, please. And the Nehal Nevgi, that is 3.7. But answer is 7 point. Okay, okay, 7.23. If you if you are having any problem, okay, okay. If you are having any problem, please tell me, because this is a basic question and this is the assignment one only. Okay, so I am just repeating, because Okay, the surface charge density equal to total surface charge divided by area. So the area is 4 pi r square in the spherical particles. So and carboxyl group have one electron. So that's why the charge on one electron is equal to 1.6 10 to power minus 19 coulomb. Okay, so number of charge that is given in your question 2.3 into 10 is to 5. You have to just calculate by charge to calculate total surface charge and divide it by the area of the colloidal particles. So these are some simple mathematical calculations, and after that you have to just convert the units. Okay, I think that is okay now. Okay, here I have just converted coulomb into micro coulomb. Okay, and the micrometer to centimeter square. Just the simple calculations are there. Okay, so should I go to the next question? The next question will be just a theoretical based question. Should I go? If you have I am again asking, if you have any doubt, please ask me in the chat box. Okay, I am going to the next question now. Okay, so the next question and the last question for discussion is the just you have to identify the mechanisms. So there are three figures. So first, second, and third figure. You have to just correlate the figure is for which mechanism. That is, these are some options given here. First one is the sedimentation, and the coalescence, and third is the aggregation. You have to just be specific for these mechanisms. So what will be the right option? You have to just correct it. Okay, you have to just match. So I will be just waiting for your response, and after that I will explain it. Okay, so please try to respond. Oh, unable to see the question. I will show the question. Yes, this is basically the question. This one, you have to just identify the mechanism and correlate with these three options. Okay, just try to understand. There are some clear figures. That is for which mechanisms. Okay, something here. Okay, so just just you have to correlate for the figure is for which mechanism. First one is given here, the sedimentation, second is the coalescence, and third is the aggregations of the particles. Okay, just just try to respond it, because this is a simple basic questions. uh, okay, so I am just going to explain it. So first option is given here is some one particle. Here is the I will do full screen. Okay, so here is the one particle, and it is another particle. So a larger particle formation is there. Some is trying. Okay, So the larger formation of larger particle is there. Okay, so this mechanism is basically called the collisions. Okay, and similarly, you can see here the particles are settled down. Okay, so they have no interaction affinity with this dispersion medium. So third mechanism is called the sedimentation. Okay, and the remaining one you all know is the aggregation. Okay, so in earlier stages, when the Brownian motion arises due to the thermal energy, so there is some uh, 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 colliding of particles with each other, and later stages they will form the aggregates. Okay, so the third options will be appropriate for the aggregation property. Okay, so I think this it was my last question. So I think everything is clear. Oh, answer is that is second aggregation. But for which figure? Please mention. Okay, I have just explained this question. So if you have any problem in these questions, you can just write to me. I will go to that specific questions. Maybe that questions was not recorded in my session, but these are the basic questions you already know. Okay, just try to solve the similar problems. Okay, if you have any question, please uh, type in the chat box or you can directly say to me. Otherwise, I will just stop here. It is okay with you? No questions. Okay, I think that is all clear. Hmm. I am waiting for another other candidate also. If you have any question, please type. Okay, I am just no questions. Okay, okay then. Bye bye. This is all about. This was all about this first session. Meet you in the next sessions. Thank you very much for attending. Thanks a lot.